you cannot always factor quadratics. So when you cannot factor quadratics, you don't have the choice, but you must be using quadratic formula. So the quadratic formula, let's just write out what the quadratic formula is negative b plus or minus square root b squared minus 4ac all over 2a. This formula is not going to be given to you on a quiz or on a test. It is expected that you memorize this formula, but hopefully you've memorized it in the past. If you forgot it, you can just put it right back into your brain. It shouldn't be hard to rememorize, right? You do need to write x equals in front of your final answer. I don't care if you bring it down every time, but before you circle your answer, make sure you have x equals, because what you're indicating here are the x-intercepts. So you're saying the x-intercept is at the x value of, and then whatever this answer would give you. So I do need to see x equals, so you're showing the answers of your x-intercepts. Once again, the reason why we do the quadratic formula is because sometimes you cannot factor, and if you cannot factor, you don't have a choice but to use the quadratic formula. Sometimes the reason why you can't factor is simply because factoring is a shortcut. We do those, multiply this times this, and try to add to that middle term. Sometimes it's not so pretty that it physically would add to the middle term, at least not with whole numbers. And so that's one instance where we have to factor. Sometimes we don't have the ability to factor because you will have non-real answers. Non-real answers are numbers that contain the square root of -1, because the square root of -1 is indicated by an I for imaginary. So this would be the case that you end up with your imaginary solutions. And imaginary solutions happen because what happens is the quadratic doesn't actually cross the x-axis. But we still want to get an answer for that. We're just saying that it's not, the quadratic answer is not going to be a real number. It's going to be imaginary in this case. So before we start actually applying the quadratic formula, we're just going to review some radicals and some imaginary numbers. So in example 1, we have 2 times the square root of -64. So as soon as you see this negative inside of the radical, you know that's not really allowed to happen. That's going to come out of the radical and become an I. So you have 2I square roots of 64 is the equivalency of 2 square root of -64. And so I'm kind of doing this very step by step because next you would say, well, 64, I know that that's a perfect square. It not only contains a square, but it's actually a perfect square itself because 8 times 8 is 64. So square root of 64 is 8. So we have 2I times 8. And just think of I as a x almost. And so you could go ahead and multiply 2 times x to get you a final answer of 16I. All right, so in our next example, do y'all have this little extra square root right here? It's super weird. Okay, so our next example is the square root of 4 squared minus 4 times 4 times 4. I'm just rewriting it because that square root's bothering me. So 4 squared is 16. 4 times 4 is 16 times another 4 is 64. So 16 minus 64. This is the real reason why you have your calculator out, is because 16 minus 64 can be hard to subtract. If you have a hard time subtracting that, type it into your calculator. If you don't have a hard time, you know 64 minus 16 is 48, so it's got to be the negative version of that. So it's negative 48. So we have the square root of negative 48. Now that you see a negative inside of the radical, you know that you're going to take that negative out and make it an I outside of the radical. So I have I square roots of 48. But is there a perfect square that is inside of 48? 16. 16 is a perfect square that's inside of 48. So that's what I'm trying to pick here, and it's 16 times 3. The benefit of picking 16 is I know the square root of 16 is 4. So 4 is going to come out of the radical with that I. So I have 4I, and then 3 is left inside of that radical. So 4I square roots of 3 would be a final answer here. Okay. All right, let's do another one. So simplify the following. Negative 2 plus or minus square root of 2 squared minus 4 times 8 times 1 all over 2 times 8. So this is kind of what we're going to be doing, but it's already plugged in for you. And then we'll start into what we're actually doing today. So I simplify one thing at a time. Negative 2, I can't really do anything with that. Square root of 2 squared. Well, I know 2 squared is 4, so I still have that negative 2 plus or minus square root. Instead of 2 squared, I'm going to write 4. 4 times 8 is 32, times 1 is still 32, so minus 32, all over 2 times 8, which is 16. But what is 4 minus 32? Negative 28. So now I have negative 2 plus or minus square root negative 28 all over 16. I'm going to go very step by step for the first couple, and then we're going to start skipping a few steps here and there. Okay, so I see that I have a negative inside of my radical. As soon as I see that I have a negative inside of my radical, I'm going to say I don't want this negative inside of my radical right here. I'm going to pull it out. It's going to become an I. So I have negative 2 plus or minus I. In addition, in the same step, I'm going to simplify 28, because now 28 is just a number. What is the highest perfect square that goes inside of 28? 4. So it's 4 times 7 equals 28. The reason why I'm choosing 4 is because the square root of 4 would come out of the radical as a 2. So I have 2 right here, 2I, square roots of 7, all over 16. It is now at this point that you can simplify the fraction. You should not attempt to simplify this fraction until you have done everything you can up top. When we started way back in August, we kind of talked about when to simplify radicals, and the basic underlining idea is radicals only simplify other radicals. So this 7 is stuck inside of the radical. He's never going to come out. He's not going to divide. He's stuck. But this 2 and this 2 can divide by 16. What number divides 2, 2, and 16? All of which can be divided by 2. So I'm going to take each one and divide by 2. So I get a final, this is going to be our final answer. Negative 2 divided by 2 is negative 1. 2I divided by 2. 2 divided by 2 is just 1, but I still am going to have that I. So negative 1 plus or minus I. Root 7 is stuck inside. He's never leaving. All over 16 divided by 2 is 8. This would be the final answer that I would expect to see x equals in front of. Okay. All right, so let's apply it to a real quadratic equation. So f of x equals 3x squared minus 4x minus 1.
So it become positive 4?
It will. If you wanted to try to factor, I don't think that that's a bad idea, because I am going to throw things on there that you can factor, but as you saw, you could also do quadratic formula. But factoring is much easier. So if you try to factor here, you would do 3 times negative 1, which is negative 3. Multiples of 3 are 1 and 3. Can 1 and 3 add to negative 4?
No.
Actually, it can. Negative 1 and negative 3? Right. But the problem with negative 1 and negative 3 is that if you multiplied these two things, they are not going to multiply to negative 3. So factoring is not going to work here. So we must use the quadratic formula. So the quadratic formula, A equals 3, B equals negative 4, C equals negative 1. So negative B, negative 4, because B is negative 4. So negative B plus or minus square root negative 4 squared minus 4. A is 3, C is negative 1, all over 2A.
That inside
Okay, just because you have a calculator, do not start relying on your calculator like crazy, because a lot of you are going to type in negative 4 squared on your calculator, and it's going to give you negative 16 because you didn't put it in parentheses. But if I asked you without a calculator, what is negative 4 squared, what would you say? Positive 16. Okay, what is, look at the 4 times the 3 times the 1. Just the number of that is 4 times 3 times 1 is 12. If you see two negative signs, are you going to be adding 12 or subtracting 12? Adding 12. I really do not recommend using your calculator. It is only for that subtraction of negative numbers is really the only reason why we let y'all have it. Okay, so I'm going to start simplifying. Negative 4 is positive 4, plus or minus. 16 plus 12 is 28, all over 6. Okay, I'm not a negative radical, so this is going to be some real answers here. Furthermore, 28, what's the perfect square inside of 28 again? 4, so 4 and 7, 2 is going to come out. So 4 plus or minus 2 square roots of 7 all over 6. It is at this point, only when you are done with your top, do you look at your numbers. So your numbers are 4, 2, and 6. Can they all divide by something?
Yes.
What number are we going to divide them all by? 2. So 4 divided by 2 is 2, plus or minus. 2 divided by 2 is 1, which I'm not going to write, so root 7. And 6 divided by 2 is 3. That's a final answer, so x equals. I want you to have the x equals. All right, so let's go on to example 2. X cubed plus 9x. If I have x cubed plus 9x, can I apply the quadratic formula to a cubic function? No, but what can I do with this before I start? Say it again. Greatest common factor. You should always look for a greatest common factor. So I'm going to greatest common factor out in x. And I have x squared plus 9 left over.
So you have 6.
That's difference.
Oh,
Okay, what is the point of factoring? Why are we factoring? To get the answer. That's it. That's why we factor. So, x is a factor. X, set it equal to 0, is an answer. So, this gives us one of our answers, and it's x set it equal to 0. X equals 0. So, I already have one of my answers, and it's going to be x equals 0. What that means is that if you were to graph this cubic function, you should find that this cubic function crosses the x-axis at 0, or at the origin. But there are going to be two more answers, and it's from the leftover quadratic. So what's left over needs to get us two more answers. So left over is x squared plus 9.
wait, that wouldn't be x minus 3 and x plus 3.
Why is it not x minus 3 and x plus 3? What is she trying to do? That's called difference of squares. Is this a difference of squares?
That's okay, the plus. Okay.
Yes.
Yeah.
Okay, but this is a quadratic. You could definitely do quadratic formula with a of 1, b of 0, and c of 9. And you would get the correct answer, for sure. But the reason why we have to do quadratic formula is because typically our quadratic formula has an ax, a bx, and a c. And there's no way, if I go back to this example, there's no way to isolate x. You can't solve for x. Algebraically, that's always our goal, solve for x. There's no way to solve for x when you can't combine these as like terms. They're not like terms. So we have to do the big, long formula. But x is already solved for. I mean, x is already isolated. I could simply say x squared plus 9, I need you to equal 0 because that would give me more answers. If I subtract 9 and I take the square root of both, what happens when you create a square root that was not originally there? Plus or minus. What's the square root of 9? 3. And I, because it's negative. So x equals plus or minus 3i. If you did the quadratic formula, that would certainly be fine, and you should get the same thing. This is just much easier. You couldn't until today. Okay, so we do have one answer, 2, 3 answers. I have 0 as an answer, 3i is an answer, and negative 3i is an answer. But only one of these is real. So how many times are we going to see it cross the x-axis? Only once. This is really getting into what we're talking about tomorrow, but you really need to understand the idea that real solutions are represented by crossing the x-axis. Imaginary are just extra solutions that they have. Okay. On example 3, we have 2t cubed minus 40t. So, of course, this is really starting off just like we did earlier. We're going to greatest common factor, but what are we going to common factor out? 2 and a t, right. Greatest common factor. You do as much as you can. So 2t leaves inside t squared minus 20. The fact that 2t is a factor says that 2t equals 0 is a solution. If I divide by 2, t equals 0. So far I have one answer, and it's that t equals 0. All right, t squared minus 20. Again, this is very similar to the example we just did. You could do quadratic formula, or you could simply say t squared minus 20 equals 0 is going to give us my other two answers. If you want to do difference of squares, that's good too. Add 20 and take the square root. When you take the square root that wasn't originally there, You create the plus or minus answer. What's the perfect square that comes out of 24? So 4 times 5 is 20. I pick 4 because the square root of 4 is 2. So final is t equals plus or minus 2 square roots of 5. Two square roots of 5. Is that a real or imaginary solution? It is a real solution. If you graphed this on your calculator, you would have it crosses the axis at the origin. That's represented by the 0. It crosses the axis at negative 2 square roots of 5. It's like negative 4.7 and positive 4.7. So this would be an approximation of what you would see on your calculator. Of course, that should cross right there. Okay? Yeah. Basically. All right, let's do the last one. 10x cubed plus 7x squared plus 4x. So how do I start? GCF x equals 0. So if I pull out that x, I'm left with 10x squared plus 7x plus 4. Okay, so this tells me x equals 0 is an answer. So far I have an answer, and that answer is x equals 0. I know it's going to cross the x-axis at least once at the origin. If you notice today we're doing a lot of zeros. We got to get away from the zeros, but for now, the zeros are the easiest to find, so that's what we're doing now. All right, what's left over this time is a full-on quadratic. It has an a term, a b term, a c term. This is not as easy as the past two. You can't just set it equal to 0 and go. This one, we must apply the quadratic formula to 10x squared plus 7x plus 4. So I'm going to say a is 10, b is 7, and c is 4. All of those are positive here. So my quadratic formula is negative b, negative 7, plus or minus square root b 7 squared minus 4 a c all over 2a. Okay, so let's simplify where I can. So negative 7, that's simplified. 7 squared is 49. 4 times 10 times 4, someone type that in. You get 160. What is 49 minus 160? 111. So we have negative 7 plus or minus. Is it 111? Is it negative? Negative 111 all over 20. Negative 7 plus or minus I root 111 all over 20. You have to check 111. I think I've talked about the trick of dividing by 3. If you 1 plus 1 plus 1 is 3, which divides 3. So 111 for sure divides 3. What is it? 3 times 37. Is 3 or 37 going to break down any further? No. So this is as simplified as it gets. Now check the denominator. Does 7 divide by 20? Does 1 divide by 20? No. Doesn't all three of them have to divide by something? They don't. So this is final. So x equals negative 7 plus or minus square root 111, I forgot my I, all over 20. Any questions? All right, y'all do the bottom two.